In this session, we'll take a look at the normal distribution. And as you see, the blue curve, this is the normal curve. You may hear it referred to as the bell-shaped curve because it kind of represents a bell or a Taco Bell shape. And these distributions are important because only certain types of statistical procedures can be carried out by using this type of curve only. Normally distributed data fits this type of curve. So you may ask, what is a normal curve and what is normally distributed data? Well, we have certain examples of normally distributed data: height, birth weights, grades. So for example, if we were to take the grades in this stats course, and if we look at this normal curve, notice that there are going to be very few students that score in the lower levels. So keep in mind that probability is area, right? So at the extreme low end, notice that there's very little area. Conversely, students with very high scores, right? Notice that again, there's very little area above. So there's going to be relatively few students that score at the very, very high levels. The majority of individuals or the majority of area is concentrated somewhere in the middle, right? So that's an example of normally distributed data. There's not too many data points on the low end. There's not too many data points on the high end. The majority of the data points are somewhere in the middle. So let's take a look at how that relates to the mean and the standard deviation. So keep in mind as we go forward, the probability is the area and vice versa. The area is the probability. So in these problems, you'll be asked to find the probability. You're actually asked to find the area. So as we sketch out this normal curve, the middle would contain the mean, right? So here I'm going to write the mean out as mu. If I go one standard deviation about the mean, so I'm going to sketch out mu minus sigma and mu plus sigma. And between one standard deviation of the mean, we have 68% of the data, which means we have a 68% area, which equates to 68% probability. If we go out two standard deviations about the mean, so here we have mu minus 2 sigma and mu plus 2 sigma. And between two standard deviations of the mean, we have 95% area or 95% probability. And if we go out to three standard deviations about the mean, we have 99.7% of the data between three standard deviations of the mean. All right, so keep in mind from this point, probability is area. So we're going to take a look at a couple of examples. Now we're going to work out the probability a couple of ways. We're actually going to use technology. I'm going to use a graphing calculator, the TI-83. You may or may not have a TI-83 calculator. It was not actually a requirement for the course, right? But if you've taken our classes here, we use the TI-83 in our other courses. So if you have one, I'll go through the steps using this calculator. There's also a normal distribution website. Okay, and I'm going to pull up this website. I'm actually going to post it in the announcement section. And you can follow along and use this normal distribution calculator as well. All right, so let's take a look at an example. So here we're given given a normal distribution with a mean of 10 and a standard deviation of 2, and we're asked to find the probabilities of these shaded figures. Okay, so we have an A, a B, and a C. All right, so let's look at A. All right, so we're asked to give the probability that X is less than 6. Okay, so in my calculator, I'm going to go into distribution, and since it's yellow, I'm going to hit second in variables, which is distribution. And for these area problems, I want to use the normal CDF. Okay, so the norm, I'm going to explain these two. The normal PDF, it would give you the area or the probability at a value. So let's say if we wanted to find the probability that X equal to 6, right, we would use the PDF. Since we're finding areas greater than, less than, and compound areas, we're going to use this normal CDF. CDF alludes to the cumulative distribution function, right? So let's see how this works. So I'm going to use the cumulative distribution function. Now, as we use this cumulative distribution function, it's going to require 4 parameters. So I'm going to list those parameters here. So when we use the normal CDF, you must put in the following. You must put in a lower bound. You must put in an upper bound. You must put in your mean, and then your standard deviation. All right, so let's see how this works. So notice I'm gonna use a number that's to the far left. Okay. So for these instances, I'm gonna use negative 100 and I'm gonna use positive 100 as my extremes. So for this normal CDF, I'm gonna put in my lower bound, and here I'm gonna use negative 100. I'm gonna put in a comma. I'm going to put in the upper bound, which is 6. I'm going to put in the mean, which is 10. The standard deviation, which is 2. And we have our area, 0.022. Or if I round, 0.023. All right, let's take a look at B. So here we're actually finding the probability that X is greater than 8. So our probability is area, so we want to find the area under the curve greater than 8. So I'm going to use the normal CDF once again. I'm going to put in my lower bound, which is 8. I'm going to put in the upper bound. I'm going to use positive 100. Once again, the mean is 10. The standard deviation is 2. And we have an area or probability of 0.841. And if we take a look at the last example, we want the probability of X being greater than 12 and less than 14. So once again, I'm going to use the normal CDF. I'm going to use the lower limit of 12, the upper limit of 14. Right, 10 is the mean, 2 is the standard deviation, and we have 0.136. So now you may not have the graphing calculator, so I'm going to now use the applet. Okay, now I didn't invent this or anything, I just sort of pulled it offline. All right, so here's how this applet works. All right, so I'm going to go back up to the top. So notice we have mu, we have standard deviation. So I'm going to put in the mean of 10. I'm going to put in the standard deviation of 2. I'm going to put in the x value of 6. And notice that we have some options for shading. So if I click on in my drop-down menu, notice that it gives me greater than. Okay, and that's not really what I want, right? I want less than. So I'm going to change that inequality to less than. And this is exactly what we want. And notice we're given the area, 0.023. All right, let's look at the next example, B. So I already have in the mean and the standard deviation. I'm simply going to change my value for x to 8. I want to make sure that I have the correct shading, so I'm going to change my inequality to greater than. And notice we have the value, 0.841. Right? It gives us the probability, which is the area. Now for this last example, notice that I don't actually have that compound inequality. So in order to find this area, I would simply find the area from 12 to 100. I would then find the area from 14 to 100, and I would subtract the difference. Right. So here's what I mean. I'm going to change my x value to 12. Right, so notice that gives me the area from 12 to positive infinity, right? And I don't want it to positive infinity. I only want it to 14. So I'm going to take this value, 0.15866, and I'm just going to jot this down on the side, 0.15866. Next, I'm going to change my value to 14. Right, and I have this area 0.02275. And now if I subtract those two areas, 0.15866 minus, I'm going to put in 14. 0.02275, and we have 0.136. All right, next we'll take a look at the second problem, number 2. All right, and problem number 2, it deals with what are called z-scores, right? And so here's the definition of a z-score, or a standardized normal curve. All right, so for a z-score, a z-score is no more than a normal distribution the z-score is from a normal distribution with a mean of 0, right? So the mean would have to be 0, and the standard deviation of 1. So the problem that we looked at prior, it had a mean of 10 and a standard deviation of 2. That's not considered to be a standard normal curve. A standard normal curve would have a mean of 0 and a standard deviation of 1. Therefore, that curve looks something like this. The mean would be 0. And our x-axis would be scaled as such. Okay, notice that if we're dealing with a standard normal curve, we have z-scores that range from -3 to +3, right? So we can standardize any curve to a standard normal curve. And we have what's called a z-score, right? So here's a calculation for a z-score. A z-score is equal to x minus mu divided by the standard deviation. So as we take a look at problem numbers, a normal distribution has a mean of 22 and a standard deviation of 3. Using z-scores, answer the following question. Find the probability of a value between 13 and 31. Right, so we can find that probability. All right, I'm just going to bring up the calculator here. So we could find that probability. Right, I could pull up the normal distribution, CDF. We're given a mean of, or we're given a lower bound of 13. We're given an upper bound of 31. The mean is 22. And the standard deviation is 3. And we have a probability of 0.997. Right, and then we're asked to shade. So we're dealing with a compound inequality, so we're going to shade between two values. But then we're sort of running into a problem. Right, I don't see 13 and I don't see 31. I have the z-score layout. Right, so how do we convert this raw data into a z-score? Right, well, we're going to convert 13 and 31 in the z-scores by using the formula. All right, so we're going to convert 13 and 31 to z-scores. All right, so first we're going to start with 13. Okay, but before we actually start with 13, let's see, the mean is 22 and the standard deviation is 3. All right, because we're going to need those two values in the calculation. So first we're going to do 13. So the z-score for 13, that's equal to x. So x is going to be 13 minus mu, right? And mu is 22 divided by the standard deviation, which is 3. So we have 13 minus 22, which is -9. 9 divided by 3 is -3. So now we're going to convert 31 to a z-score. So again, that formula is x minus mu. So x is 31 minus mu, which is 22, all over the standard deviation of 3. So 31 minus 22 is 9. 9 divided by 3 is 3. All right, so we have our z-scores from -3 to +3. So I'm going to go back and graph. All right, so I'm going to just slide this to -3 and to +3. Now I'm just going to double check this with the calculator, right? So I should get the exact same result. So I'm going to go into distribution. I'm going to hit Normal Cdf. I'm going to put in the lower bound, which is -3, comma, I'm going to put in the upper bound, which is +3. Since I'm dealing with a standard normal curve, I do not have to put in the mean and the standard deviation. The calculator recognizes that. All right, so lo and behold, we have the same area. Thanks for watching.